So from my perspective, there's really three main things you need to address. The first is the fundamental basis of indoor air quality for general health and to make sure people are comfortable. Then we have to tackle fine particulate matter, outdoor air pollution. We saw it with wildfire smoke this summer. Smog and pollution are leading killers. So that needs to be addressed as well. It hasn't been adequately addressed until now. And the third big problem we have is airborne diseases. So if we address all of those, we've really done a good job at creating low-risk spaces. So the first technology which we need everywhere is ventilation. It's supplying outdoor air to the space. Usually indoor air is much worse than outdoor air. So it helps, but if there is lots of outdoor air pollution, then there's other technologies that could be better. You can verify that you're getting the adequate amount of ventilation from carbon dioxide monitoring. That should be something that everyone uses moving forward. The next step, this is low-hanging fruit and really needs to be done everywhere, is MERV 13 filters, both to protect against outdoor pollution and also you clean recirculated air from any airborne pathogens. So once we have addressed ensuring adequate ventilation in the space and upgrading the filtration to MERV 13, and those are always the fundamental basis, at that point, we need to introduce additional air cleaning in order to control infectious aerosols. We now have a standard on how to do that. So what you do is you find out how much air cleaning you're currently providing, find out how much is needed, and then you have to make up the difference. So we have lots of different options on how to do it. So one is just increasing the ventilation rates further. The next is in-room air cleaners, HEPA filters, Corsi-Rosenthal boxes, or ones with UV. Then there's a few different ways to use UV inside the room. One is upper room UV, far UV, and what's called the Dibel system. Upper room UV is really a technology that I think needs to be considered much more moving forward. You could get extremely high clean air delivery rates, 20 to 30 air changes per hour. We have evidence from measles, TB, influenza, and with COVID that this is a very effective tool. Far UV, I think we need better evidence on what power we should have in order to make sure that when it's used, it's safe and effective. The Dibel system, which a lot of people probably have never heard, it's called direct irradiation below exposure limits. This is what far UV is essentially. You're just using UV LEDs that are at a longer wavelength, and you could shine it into a room. So you're not going to get as high intensity as you would from far UV, but it still could be effective.